Great. So as Naveen said earlier, we're gonna go ahead and start off with some vectors. Okay, so vectors are extremely similar to arrays. They're storage device that can hold many slots of memory. They can be allocated dynamically. Arrays often have like a defined set of slots that you can have hold for memory. You can't really expand arrays, but vectors variable size, making them preferable to arrays in most situations. And like arrays, vectors can be multidimensional, like 2D, 3D, etc., etc. So the first thing to do with vectors, as we often did with like input and output, is to include the header file. So the header file is fairly simple. Just include and then vector, and that's basically it. Now you have vectors within your system, and you're allowed to use their functionality. So as arrays, you have to go and define a vector. So that's pretty simple, a vector. And then within this sort of less than or greater than symbol, you go ahead and define the type of vector that you're going to be using. So we went over variable types a while ago, but of course, int, boolean, character, double, string, etc. So for now, we'll just use integers. And then the name of your vector, so I'll just call it myVect, and that's it. You just defined a vector. So the general form, I'll list it right here, would be just vector, and then type of vector, and then vector name. So that's the typical format of creating a vector. Now, of course, we can do this with multiple types. Boolean, boolvect, vector doubles, etc., etc. You get the idea. So now that we've defined a vector, you can go ahead. So it's very in size, right? You can go ahead and change. You can go ahead and add stuff to the vector. So in arrays, we usually used to define it. For example, we used to like put it into a for loop. Or just say like vect the name of the array, and then within brackets the location. You can do a certain thing. But in vectors, you can do something called pushback. So you can do, for example, myVect, and we can do dot pushback underscore back, and then the value they're about to push back. So, for example, we could put a value of 4, and then we could also push back a value of, let's say, 76, and another value of 5. And now if we go ahead and output everything we have, we will see that we'll get everything that we just ran right here: 4, 76, and then 5. So I forgot to mention this earlier, but memory allocations for a vector can be accessed the same way as you do in an array. And then, of course, you can also store vectors, traditionally with the size like that, and you can set it equal to the number of stuff that you want. If you leave it open, it's just a bunch of zeros. Then you can dynamically set it to like 9, 7, 6, etc., etc., like you do with an array. Okay, I'll give it off to Naveen for now. Naveen, I believe your mic is muted.
Right. Sorry about that. I didn't realize that my mic was muted. All right. So we can make vectors with any variable type. So let's go ahead and make a vector of characters. And just to remind everyone what a character is, a character can include anything with an @ symbol, a number, or anything. So let's go ahead and make that vector. So the general form of a vector is the word vector itself, and then with a data type enclosed within a greater than sign and a less than sign. First is the less than sign, and then is the greater than sign, and I think you all can see that. And then after that, you type in the name. So let's go with anything, let's go with C for now. So if you want to push something back, push back. Rebel's already giving a suggestion. And then if you want to push something back, you're going to have to use quotations, single character quotations, and then you can push back the value. So as Puneet stated, you could use array notation to access the data stored within a vector, but you could also use some other notation that's specifically used for vectors only. And let's go ahead and take a look at that. So for Puneet's vector, we write another for loop. Then we can also put cout my vect, and this is the other way to do it. Access the memory is to put dot at, and then you put the number of the slot that you want to access. So we're going to go with I again, and then we can end the line. If we run it outputs the same thing twice, which is exactly what we wanted. So now it's time. So if you want to initialize more than one, so now we know how to push data back into the vector. But if we want to push in many things at once, or just initialize the vector with, let's say, 3 or 4 or 5 things, because it can be a little tedious to write. After he stored in 3 things, but we want to be able to initialize them all at once. So in order to do that, we'll go ahead and use curly brackets, similar to what we do with an array. Vector int. We use camel case, and then you put curly brackets, almost exactly like what you do with an array. And then we end the line. So that will store 10, a 20, and 30. The 10 will be in the 0th slot, the 20 will be in the 1st slot, and 30 will be in the 2nd slot. And then there's another way on top of this to initialize. This way it initializes the size of the vector and all the values at once. So let's go ahead and define a variable, something like that. And then if we, let's say, call it an integer, most of the vectors in today's lecture will be all integers. And then let's call it myvec3. And then we put parentheses, and then you put n comma 3. See what this does. So what this does is that the thing in the first part of the parentheses, that is the size of the vector. That says the number of slots the vector has for data to be stored in. So since we have n equals 4, that will have 4 slots, 0, 1, 2, and 3. I don't know what happened there, but, and then each one of those will be stored as a 3. Yeah, we'll go ahead and fix that. So that's how you can initialize the vector with more than one variable at a time. But vectors can also be multi-dimensional, just like arrays. So in arrays, we use multi-dimensional arrays to store more complex data types, and the same thing can be done with a vector. The trick is the defining part with the multi-dimensional vector can be a little tricky. It essentially comes down to putting a vector inside another vector. So let's go ahead and write this out. Vector and the name of the vector is going to be vect. Let's make it more clear. That's a little confusing. Just for the case, just to make the symbol, I'm going to make them all one-dimensional long. And then, so some people, they like to separate them out by entering it. Hold on, I'm going to try to line this up with the Puneet's screen here. So, yeah. By doing so, they can more easily see where the vector slots are in the 2D area. So you can add more variables in, a 1, 2, kind of 1, 4 here, any things that you want. So that's essentially how you initialize a multi-dimensional vector, and you can also access the information the same way that you would with a single dimensional vector. And yeah, I think that covers 1.1 of the lecture. And Puneet, go ahead.
Yeah. Thanks for that, Naveen. So now that we know how to essentially define vectors using both a shorthand notation and by pushing back multiple things using an for loop. So we're going to give you guys a task. So we're just going to store the integers 1 through 100 in a vector. And you have to do it both ways that we just showed you. One using the parentheses method that Naveen highlighted here. And the other one is using a for loop by using pushback. We'll give you guys 2 minutes for that. Okay, so it seems like it's been about 2 minutes. So we'll go ahead and store the integers 1 through 100 in a vector using a for loop. Just type this out a little bit cleaner. Okay, so the first way that we can do this is by essentially just doing a for loop and pushing all the values back. So we're just going to create a vector of ints, and let's call it for vect, right? And we'll just do just for int I is equal to 1, I is less than or equal to 100. Yep, store integers 1 to 100, then I plus plus. Let's go ahead and say for vect dot pushback. Oops. Let's push back the value of I. So every time the first iteration will be 1, then 2, then 3, then 4. And then we'll go ahead and output it as well. Oops, forgot this. And then we're going to output this, and we'll see the values 1 to 100 pop up on the right side of your screen. Now, we can do this another way. That would be with the end size loop that we talked about earlier. So what we could do is that we can make another vector of ints. Let's call it endVect. And let's set the size equal to 100. And let's set all of them equal to 1. And then what we can do is we can make a for loop int I is equal to 1, I is less than or equal to 100, I plus plus. What we can do is just have endVect the value I plus or equal to or actually it'd be easier just to set this equal to the value of I. So that way we've defined and if you go and output this, then we'll see the numbers 1 to 100 appear, and then the numbers 1 to 100 appear again. So that's 2 ways to use vectors to set integer values to it. So now that we know how to use a little bit of vectors, now we can get into some of the intricacies of vectors. So as we talked about earlier, we can use the dot push back button, which is really useful when we're trying to make it a dynamically stored data type. But as with vectors, there's other dot commands that we can use with it. The biggest one would be dot size. So for example, we can output for vect. Actually, we'll just do nvect dot size to the console, and we know the size is 100. But let's see if the nvect dot size actually comes to the correct answer. That's it. We got 100 again. So what nvect dot size can do is essentially give us how many values are in the vector, and we can perform some loops on it. So instead of doing a single 100, we can change all these 100s back to nvect dot size. So if you do that, we should get the same answer. There you go. You got the exact same answer. So now Naveen's going to teach you a more complex version of using these loops.
Right. So now we all know how to use for loops, while loops, do while loops. But there's another type of loop that we didn't mention in the last lecture, and that is a range-based for loops. And that's because we wanted to introduce them after we introduced vectors. So a range-based for loop is similar. You define an integer within the for loop that can only be accessed within the loop, just like in a regular for loop. But the integer that is taken in is every integer that's within the vector itself. And this can be a little confusing, so the best way to explain it is doing the code itself. So just write something out for int I in, let's go to my vex2, whichever one that is. And then we output whatever I is there, then we should see something on the right hand side. And that's exactly what we had in my vec2. If we scroll up, my vec2 had 10, 20, 30 stored inside of it, and that's exactly what it outputs. So what the range-based for loop does is that it takes every integer within my vector, within the vector itself, and it uses that for the code, and it runs the code based on those integers. So the number of times the code is being run is exactly the same as the size of the vector itself. So this is identical to using a regular for loop that is just based on the size itself, as Preet talked about a little bit ago. So if we put I is less than my vector size, and then we add a plus I, and then we are typing the exact same code before. Except this time we're going to have to actually access the value within the vector instead of just using I, because this time I isn't the value of the vector of the data type itself. So if we output this, we should get the exact same answer twice with two sets of 10, 20, 30. So that's exactly what we see, which is perfect. But the trick is that sometimes you might not know what type the vector, you might not know the data type of the vector itself. So we can let C++ handle this for us with the compiler. So if we try the exact same thing again, except we can use auto I in my vec2. So this determines what data type the vector is on its own, so that we don't have to go back and check what it is. And this is the exact same thing as before, so it should output 10, 20, 30 once again on the right side. One sec, I think my REPL's lagging out. Right, okay, so it did end up outputting 10, 20, 30 on the right side, which is exactly what we wanted. And with that, I think that covers the gist of what a range-based for loop is. And yeah, so now we're going to move on to the next task, which is to have the user input some number of integers and then tell them how many they've inputted so far. So the task is a little bit general and it's not very specific. So it's really up to you on how you want to do it. The main idea is that we just want to use a range-based for loop and the dot size function and a vector. If you manage to understand those topics, that's really the whole point of the task itself.
Okay, so it seems like it's been about 5 minutes, so I hope that's ample time for all of us to solve it. So I'm gonna go ahead and let's go ahead and solve this together. So we'll go ahead and first make a vector called integers, just for sake, and we'll make it an integer. We'll make it a boolean. Sorry, boolean continue, and set it equal to true. So we'll do a while loop. Sorry, while continue. Gee, this is popping up. You change made the cont. While we should continue, we'll go ahead and ask them to enter an integer, and of course we'll wait for their input, but they have to input into a string. With vectors, you can't directly input into a pushback, so we'll have an int temp, which is shorthand for temporary, and we'll go ahead and input that in. And we'll go ahead and just do integers dot pushback, and we'll do temp. So now what we'll do is that we'll go ahead and output them. You have inputted, right? And we'll do integers. So we want essentially how many numbers you've inputted, which would be the size of the vector numbers. We'll ask him, would you like to continue? And then we'll just say press 1 to continue or 2 to stop. And then what we'll have right here, go to another period, is that we'll have another integer called stop, and we'll go ahead and input that where we just got. Then if stop is true, stop is equal to 2, and we'll go ahead and just set continue to false, or else it'll be true. This entire loop will continue. So really quickly, let me comment some of this stuff out. Okay, the answer is enough. So if you go ahead and run this program to the right, oops, looks like I'm kind of bad at commenting. Let me comment some most of this out. Okay, I think it should be good enough. Let's run this again. Okay, so there we are. So it's going to ask us to enter an integer. Let's say 8. It says you have inputted one number. How would you like to continue? Press 1 to continue, 2 to stop. So you press 1 to continue. It'll ask us to input another integer. Let's say 87. Two numbers, we like to continue. Press 1 to continue or 2 to stop. And then let's say like 98. Oh yeah, well in this instance, we only made the stop equal to 2. So if we wanted to, we can do it right now. If stop equal to, we set false. We have an else if stop is equal to 1. We can have it equal to set equal to true. And then else, we just play an error message. You inputted the wrong number, and then we just have to input the wrong number, then exiting process, tell that to them, and we'll just set that also equal to false. So if you run this again, just to check for errors, let's say we put like 98, 1 to continue, 87, 1 to continue, 75, and let's say we press 3 on accident, and then we're exiting process and we leave the while loop. So that's a pretty small example of how we can have users input numbers and explain what it is. If you wanted to, if we finished ending the while loop, at the very end of the while loop, you can go ahead and use one of these loops that Naveen was talking about earlier. So you could do for, you have an auto I equal to integers, and we'll just go ahead and output I. So that way, if you go ahead and run this, put in a couple of numbers, and then let's say just put like 67, we'll stop, and then go ahead and output all of our integers that we were talking about. So that's a pretty quick way to do some input and output with some values. Okay, so I'll hand it off to Naveen now. He has some more to teach about these vectors, and then we're going to go on to functions.
Alright, yeah. So the next thing that we're going to be talking about now is functions. So functions can be used for many things, and they're also very useful for cleaning up code. Let's say you're going to run the same bits of code multiple times, even many times sometimes. Then you want to keep it outside of the int main. And what this does is that you can access this code at any time within the int main and as many times as you want. This can make the code more organized and just more clean overall. So when the functions can need to use data. So they're going to need to use data that's inputted from the int main almost always. So they can pass in data, or they can also use what's called a global variable. And that's just a variable that's defined outside of the int main. So global variables aren't always used, but if you don't use them, you're going to want to pass it into the function. So let's go ahead and make our first function. All right, so Penny closed it all out, but I have to scroll to the top. So let's make it a Boolean function. So if we make bool opposite, and then we would type parentheses, and then we type the thing that we want to pass in. So we're going to want to pass in a Boolean value. Let's call it bool unknown, and then we'll type the code that we want to run. So what we want to have it do is return a value, and we're going to, since it's the opposite function, we're going to have it return opposite of unknown, or not unknown, semicolon the end of line. And what this essentially does is that it takes in any Boolean that we send into the function, and we're going to call it unknown, and then we're going to return the exact opposite of that. So if we go down, so if we go down and type something new, so let's write cout, not up there. Okay, let's go to the bottom real quick. We type cout, and then we're going to call a function. So to call a function, all we need to do is type in the name of the function, and then type in the parentheses, and type in every variable that we want to input into it. So it seems that I might have spelled it wrong, or not, and then we just have to type in true. And then once we get that, and if I can type correctly, what's going to happen is that we're going to cout the opposite of true. It's going to call the function, and the function is going to return not true, which is false. Before we run the code, we should see a 0, which is exactly what we see on the right side. Perfect. So the general formula of a function is that you want to write the type. Let's go ahead and make a multi-line comment here. What you're going to want to do is write the type of the function, the type that you want to return. And if you're going to make a type, you always have to have it return, or else it's going to error out. And you also have to return that type of data, or else it's going to error out again. So you write the name of the function, and then you type the parentheses, and then you do type. Then you want the name of the variable, type, and then another name, and so on. And then you're going to want to use curly brackets, and then you're going to type in all the code that you want to run, and then you're going to return something. This just has to be the same as the type of the function, as I mentioned before. And yep, I think that wraps up the general gist of what a function is. And I think Praneet can go ahead and talk about the next type of a function. That more uses of a function, at least.
Yeah, so Naveen gave us a really basic example of how we can use a function with booleans, and we can input a value and it can output us the opposite value using, of course, a function. So we can make another function where it essentially give us a let's say like we want to do really large multiplications. We don't feel like putting it in every single time. So we can do, for example, we can have an int and we're going to call it mult, right? And let's say we take in two parameters. We'll have taken int num1 and int num2. So I wrote this comment right here, but the stuff inside the parentheses are actually called parameters. So these are stuff that you can input into the function. You don't necessarily have to input them. That we'll talk about that in a second. But you can input them, and it allows your function to run. And then since we're returning an integer, we can just put return. You have to have the word return, otherwise of course it'll bug out. And all you have to do is return num1 times num2. That's basically it. So that's a pretty simple function. You can go ahead and run it down here. So all you have to do to invoke this function, just use molt and then put in two values. So you can put 4 and 78. And then if you output that, it should give us a value. If you go ahead and run on the right, we'll see you at a value of 312. Now, with these parameters, you can also use integers. Variables. So you can have like int x is equal to 89 and int y is equal to that number. We can just do to the x times y. If you go ahead and run that right here, we'll get a pretty big number as we expected. So using functions, we can use them for a variety of values. Now, let's say for instance, you don't really want your function to take in any parameters. That type of function is called a void function. So void functions don't take in anything, but will always return some sort of something. So you can do like a void, let's say globe, for example. And since it's void, it doesn't take in any parameters, so the parentheses would be left blank. Let's say globe just wanted to print out system.out.print, and we just wanted to say, thinking Java. So we can output it, task completed, success, task completed. We can say task completed. So for example, if you wanted to run a program where every time something was run, you wanted to say task completed, but you didn't really want to invoke write cout task complete every time, you can use globe. So we can just like run globe a couple times. You run globe down here. Oops, I think I forgot to put the parentheses. Yeah, then we got it for me. Globe, it'll say task completed. And let's say like right after, you can say if you can use it in a multitude of functions. So stuff like void globe will not return anything. And then as Naveen said earlier, there's a type in the name, and then possible parameters. You can have as many parameters you want. They don't always have to be the same thing. For example, we can have a let's say we can have an int. For example, like we can have like a string parameter right here, string name. Like you can have as many parameters as you want, and they don't always have to be the same type. So the most important usage of functions would be what's something called a recursive function. So recursive functions is that they can call themselves multiple times. So a classic example of any sort of recursive calculation would be the Fibonacci sequence. So the Fibonacci sequence essentially just adding the two numbers that were right before it together to get the current number. So we can do that with a recursive function. So to make a recursive Fibonacci function, we just have to think about it a little bit. So let's go back up here. So the basic part of a Fibonacci function is to keep calling itself all the way back until we get the first two values. So we can say int Fibonacci, we just input the number that you're like, what value you're trying to get. For example, like if I wanted to get like the second number in the Fibonacci sequence, I would get 1. If I want to get like the third number in the Fibonacci sequence, I'd get 2. Fourth, you'd get 3, etc. So I have an int num. So note that if the num is equal to 1, or if the num is equal to 2, then we have to return 1, because the first value of the Fibonacci sequence and the second value of the Fibonacci sequence both give us a value of 1. If that isn't the fact, we can just do else, and we can just return Fibonacci num minus 1 plus Fibonacci of num minus 2. So what this recursive part does in the return statement is that it basically tells us is that, let's say we give a value of 3. So 3 won't really give us a value because it won't be going through the if statement. So we'll go through the else statement. Essentially calculate the Fibonacci of the number 2 plus the Fibonacci of the number 1. Now, since both of these give us a value of 1, this one will give us a value of 1, 1. So return us a value of 2. And I'll do this as long as possible until it gets to 2 values of 1, and then does all those additions all the way back up. So sometimes hard to grasp at the beginning, but you'll be able to get it. So example, if we run, let's say we wanted to get, let's say let's say the 6th value. So 1, 2, 3, 4, 5, 6. So we should get 8. So you see out fifth, 6. You go ahead and run this. Oh, there it is. 8. Seems like I didn't put an end line here. Just put that to make it easier. So if you look at the next line, we'll see that we got a value of 8. Now, of course, the higher Fibonacci sequence you want, the longer it will take. So if I want to put in 1,000, this will take a very, very long time. You can see the process is still running, but eventually it would come to the same answer we were talking about earlier. So recursive functions that you go through as many steps as possible until it gets to the final step. So really good question coming in right now of how does the computer know how to do recursion? The computer knows how to do recursion is the return statement that we talked about right here. So when we're returning the value, we're just returning the same function all over again. We essentially recall it. So that's the statement right here. This is return function. So Naveen's not gonna give you guys a quick task that you guys are gonna solve.
Alright, yep, so what we're going to do here is that there's another thing in math, a little similar. It's not going to be too math heavy, don't worry. So it's just, we're going to want to calculate a factorial. So what a factorial does is that, you guys can see my screen. Alright, yeah, you guys can see it. So a factorial is typically denoted by an exclamation mark after the number, and what this does is it's equal to all the numbers times each other. And this can easily be calculated with the formula, but for now, just to get the idea in a little harder, we'll try to do this with the recursive function. So this is what you're going to want to do with the recursive function is you're going to want to call the factorial of the number right before it. So we're going to want to input a number, let's say 5, and then you're going to want to have the recursive function call for the factorial of 4 and just multiply it by 5. So that's the task.
Let's do a live solve in about, let's say, 5 minutes. Have fun solving.
Alright, so let's go ahead and make that calculator. So we're going to want to use a function as I just mentioned. So we're going to want to return an integer. So let's call it int factorial. And then we're going to want to pass in is a int num. We can call it the same thing as the Fibonacci sequence because it's not within the same function. So we're going to want to do the same thing. If num equals 1, right, 2 equals for the checking operator, then we're going to run return 1. You don't have to return yet, just going to return 1, and then else we have to return factorial of num minus 1 times by the value of num itself. So what this does is that, let's say we're going to pass in 5 as our num, or a number right now, then it's going to skip the num equals 1 because it's not equal to 1, and it's going to return 5 times the factorial of 4. And that's exactly what we want, because 5 factorial is equal to 5 times 4 factorial. So now let's do something real quick, like ask the user to input something. also really nice that REPL added the change of color for the end line statement. And then we're going to see in, so first define a number. And then just output. Of the number. Perfect. So if we go ahead and run this, as you can see, it was still calculating Fibonacci at number of 1,000. This just shows how long it really takes. Okay, yeah, I'll count that out. Okay, and let's probably put in a 4 or something. And 4 times 3 times 2 times 1, sure enough, is 24. So I think that wraps up recursive functions, and now we're going to move on to the last week's homework assignment. So take a second and pull that up. Do you have it open?
Nope, I'm working on it right now.
Okay.
Okay, I seem to have found the Google form from last week. So here was the first question. The first question is extremely similar to what we just did a while ago, except it's using a for loop to calculate the first 10 numbers of the Fibonacci sequence. So let's really quickly, let's brainstorm how we can approach this problem. So if you're going to use a for loop, then we're going to of course have a index of 0 and an end at 10. Less than 10. Fibonacci series. The n term of the series is sum of the n minus 1 term and n minus 2 term. First two numbers are both 1. We already know that. So if you try solving this problem, we'll go ahead and start a for loop. And I is equal to 0. I is less than 10. Okay. Seems like REPL is having a couple of problems. Okay, we're back. So let's just start with that int I is equal to 1. I is less than or equal to 10. Plus plus. So now, of course, we know that the first number is going to be 1. So we'll have an if statement that says if I is equal to 1 or I is equal to 2, go ahead and output the value of that, which would be 1, right? Else, which is what we're going to do right now, would essentially be is to since last time we went over arrays, we can use this actually with an array or a vector, but let's use an array for now. So we'll use an actually I think a vector would be more dynamically able to arrange for this, so let's use that. So we'll use vector int Fibo, right? So then if it's I or 1, then we can go ahead and output, we can just say Fibo of the index I is equal to 1. Otherwise, you can do another for loop in here, which would be a nested for loop. Int j, so you could use a different value, j. J is less than Fibo.size, j plus plus, and then we would do, sorry, I'm blinking right now. Anyway, could you take over? Seems to be away.
Oh, right, yeah. So, alright, I think something just fell, but okay. So we can use if I equals 1 or I equals 2. Pretty said that I is 1, which is exactly what the Fibonacci numbers are. But if for anything greater than that, we're going to want to have it equal to the sum of the numbers before it, which is also why it's perfect for a recursive function. But for this, we're going to just use for loops, as that's what was taught in the previous lecture. So we're going to have Fibo of I, because we already know it's not going to be equal to 1 or 2, because we've already said that in the if statement. And we're going to assign that as the sum of the previous two. So that will store all the values of Fibo from 1 through 10, and now all we need to do is output it, which Preet seems to be doing right now.
Yep, that's right. So we can do it less than or equal to Fibo. Sorry, just less than Fibo dot size. So we're starting at an index of 0. So if you go ahead and run this, Naveen's code real quick. Let me comment some stuff out real quick.
Oh, right. I just forgot to use J instead of I here. Classic debugging. Alright. It's enough to run. It should run. Or not. Well, that's pretty interesting. Oh, I see the problem here. I just forgot to delete Praneeth's for loop because we don't actually need one of those. Alright. So I was using it right the first time. It was eyes. Sorry for that. There's no actual nested for loop that needs to be put in.
No, I actually,
Seriously?
the problem right here is that we didn't explicitly define the size of the Fibonacci, the size essentially of the vector.
Okay,
So we can
yeah.
easily make this an integer. I mean, you can leave it the way it was. That'd be much easier. We can just go ahead and just change this to 10 and set all the values equal to 0.
Okay. Wow, so we had a bunch of errors there. Which is fine, of course. You made an array, Puneet?
Yeah, I did make it an array.
Okay, sure.
Oh, there we go. Okay, so that's the first problem from last week's homework. Let's go ahead and put in the second problem. So Naveen's gonna go ahead and solve this problem for you guys.
Oh, right. So write code in C++ that asks the user to input up to 100 numbers to an array, and if the user inputs a specific number to end the loop, and output the sum of all elements in the array. For example, the escape number can be -1 after the point. The program would output the sum of all numbers before it. All right, okay. So let's go ahead and do this. So we're gonna output enter in enter as many. How am I gonna articulate this? Enter between 1 to 100 numbers separated by a space. And we're gonna end the line there. Okay, period. Perfect. And now we're just gonna now we're gonna have to figure out a way to input all of them. So for I Puneet, could you go ahead and take over this? I'm blanking out a little bit right now.
Alright.
I'm a little confused on what the problem's actually asking.
Yeah, that's fine. So it's asking for enter 1 to 100 numbers. So systematically. So we can use a for loop or a while loop, whichever one is easier. But for this one, I think a for loop would be easier. So we're going to make an array. Let's just call it num. I don't think we've used that before. And we'll have it a maximum size of 100, as we said before. And then we'll make a for loop. Starting with the index of 0, because that'd be much easier to program, essentially with the indexes of an array. So start off with the index of 0. Go ahead and I++ this. And then what we'll do is that we'll ask them, we'll have an input. We have integer temp. And then we'll send in temp. And then if temp is equal to, we'll make an escape key essentially, int escape, and we'll set that equal to, let's say, -1 as the thing requested. So I'll have that right here. Int escape is equal to -1, and if the current one, the temporary one, is equal to the escape, then we'll go ahead and just we'll break the for loop. But before we break that, we'll just go ahead and output with sum. So far. Of course, I'm going to make an int sum, set it equal to 0. Now, the second you input temp, right, then you go ahead and set the value of that array equal to temp. And what we can also do is that we have the sum plus add it up, go to the value of array 5. So we go ahead and run this program right here. We'll have the Fibonacci sequence come up. Oops, looks like we put double equals here. Oh yeah, sorry, the name of the thing was num. Okay, so it's gonna ask us for numbers like 8, 9, 34, put in a couple numbers. And now let's put in -1, and then go ahead and output us the sum of all of these values. You can go ahead and run this again. We can, let's say, let's do some easy numbers that we know we'll get the sum of. And we get the value of 68. So that's a pretty quick example of how you could have solved question number 2 of last week's homework. So that'll be it for today's class. If you have any questions, go ahead and stick around.